Welcome, ladies and gentlemen, to another Murph Codes session. It's been a while. The whole every other week coding thing is kind of a wait, isn't it? I mean, I might just have to go to like code sessions on Thursdays or something like that so that we're at least hitting this once a week, because it feels like the whole every other, it's just too long of a wait. Anyway, last time we were struggling with the idea of creating a catalog of all of the wall spaces on our map. And I was trying to use includes, because we're working with arrays, right? That should be possible, shouldn't it? Except for some reason it isn't. I don't know what the limitations on includes is, but apparently it can't check for arrays stored in arrays. So multi-level arrays, just, yeah, no. Anyway, I found a solution that worked. We have this little toggle of flag, and then we just loop through the array that holds all of the things to see if the coordinates we're looking at are already there. If they are, flip that flag to true, and that'll tell us it's included. Okay, that's our workaround. It's stupid, nonsensical, and it's just, I didn't want to have to do it that way, but that's the way that it works. So after it loops through everything, if the flag is still false, it's gonna take a look at I and J, see if that's a wall or not. If it is a wall and not a space that we can walk on, it's going to push those coordinates as a pair to the ARGS 616 array, because if you remember, ARGS 6 is our map. 0 through 15 are the actual rows of our maze. 16, however, is not being used by our map drawing function. Because we only go up to 15. So we're setting the array of coordinates that are walls outside of the bounds of our map drawing function. So it still exists, it's just never going to get hit by this draw map to drop a tile there won't be a 16th row. It's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It gets to 16 and it's like, nope, not doing it. That's out of bounds. We've already exhausted our for loop. So we can use that 16th row. We can add as many rows as we want to add more data. But the first 15 are going to be the visual representation of the map. Row 16 is a list of just the walls. And the reason why we're doing that is because we want to be able to set up boundaries for a little slime cube. Right now you can see he just runs right through walls. Nothing impedes him. But that's because we have no checks in place to tell us how close he is to a wall. Alright? That's why we wanted to make the list. Okay, that's why we needed the list of where the walls exist at. Because within the ability to move around our little slime cube guy, we need to check for things like, okay, if he's going to go to the right, is there room for him to go to the right? Or is he going to hit a wall? If he's going to hit a wall, make it so that he can't go to the right anymore. If he's going to go to the left, same thing. You know, once he reaches a certain point and is too close to that wall, impede his progress. Up and down, same thing. But we can't do any of that until we can check how close he is to a wall. Now, thankfully, walls are only going to exist north, south, east, and west of him. Alright, and we can now judge distance between him and walls. Because we can get the coordinates of our slime cube. Args 9. Is our slime hero. Alright, this is the function that's being called. The X and Y are the change in those parameters. Now, we could set this up a little bit differently so that instead of just directly changing his coordinates, so that he's just kind of got this herky-jerky left-right motion, we can smooth that out by giving him a velocity change. And having our key presses influence the velocity change, and then with each with each frame update, instead of with each key press, it would update his position, and then we would use a gravity control kind of thing to reset his velocity so that it eventually drains. So like a key press would add, you know, a key press to the right would add 3 to his X velocity. So for the next several frames without gravity, it would add 3x and he would just drift over. As we apply gravity with each frame refresh, like it would go from 3 to 2 to 1, so it would slowly decrease, and he would, instead of this, he would kind of slide and then come to a slow stop. We'd be able to tweak that to our liking, and we will probably do that later. For now, we need to be able to do a little bit of math, be able to set up some boundaries so that he can't just run through walls and stuff. Oh, gosh. Already tired. But we have some of the math already done for us. I just have to remember where we put it. Draw map. Here we go. Okay. Do you remember how this big, ugly, long, nasty, it's just kind of scaling everything for us? We're going to need that. Because what this is translating our ARGS 7 data into pixels for us. So where are we using that? Here. We're using that in the for loop. That's 1 through 16. So as long as I and J... Did I go J-I? No, I went IJ. Okay. So as long as those are... within the bounds of our map, this math should produce something on our map. Okay, it should translate the 1 1 1 2 1 3 2 3 3 3 sort of style coordinates into pixels that we can use. Or at least that's the hope. Now, what was ARGS 7 again? Ah, scaling. Right. So we can leave that alone. What we want to do... function. We're gonna call this chord translator. Now, we can probably get away with doing this. Yeah, as you can see, every single coordinate is just an array with 2 elements. So we might be able to get away with something like calling this x, and then this would be, we have to look back here, how we're translating this on the push, ij. Although that's weird. Why is that switched? Because this was j, which is our y, and this is I. Okay, let's take a look here. Yeah, no, that's our x. This is our y. Okay. That is making some sense. Sort of. In a weird kind of way. So this is our y, even though it shouldn't be. Oh, we should probably set these to something. X is probably not great when we're talking about coordinates, unless we're actually using them for coordinates. I'm not entirely sure this is going to work. Well, let's find out. All right, so do. What I call it again? Chord underscore. Oop. Args 6 16 0. All right. Settings here. Reload. Let's try that again. There it is. And as you can see here, well, maybe not, it might be a little too small, but we're already instantly getting a return value. All we're doing is we're plugging in sequence each of the values of that args 616, which has 145 walls on it, apparently. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, we know that's 15. 15, so that's 30 plus 4, 13 and 13. That's 26. So that's 56 right there. 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45 walls, 145 walls, exactly. So, we have the coordinates of every single wall on a single integer count plane, but then we also have our function that can turn those into exact pixels. So let's, for example, take the, let's see here, we have 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You know, let's try to pick one towards the middle here. Let's try this one right here. Actually, no, we need one we can easily count to. Alright, if we go with the 8th one, chord translator, args, 6, 16, 8, we get 31 and a negative 317. Right now. If you recall, what we're doing there is drawing an image, but we're also feeding it our canvas height and width as the center point. So this is from center. Not from top left, not from up here, but from the center. We are 31 over. And we are 317 up. Because negative is going up. Our 0 line is, our 0 axis is there and there. Negative x, negative y. 0, 0 is in this vicinity. So, we have to remember that we are translating. Still, even with our draw image, because we're not using directly draw image. We're using draw slime, draw dust. So if we wanted to, say, draw a boundary around... Which one did I go with? The 8th one? The 8th wall? And we just used the canvas, like, draw circle method. We're gonna have to remember that our coordinates are being translated still from the canvas's height and width, because we're using a very flexible canvas. Remember, if we slide this around, like, our canvas redraws to the size of our window, so the height and width are constantly changing. And in order to keep our game board center at all times, no matter what size screen we end up displaying on, we're using a bit of math magic. We're dividing the height and width by 1/2 and using that center point as our reference instead of our top left, which you would normally use in a canvas element for drawing from. But that's only helpful if you're never expecting your canvas to redraw itself. If you're never expecting your window to ever resize. We thought ahead and we're like, oh, they can resize that. So we want to make sure. And we've also got that scaling factor. So as we make our window larger and smaller, it will step down through 3 sizes. There's large, medium, small. Now, thinking ahead through these factors does make our game more responsive to the sort of environments it might display in. It does make our coding a little more difficult. thankfully not much more difficult because we've already done this. We've already factored in those elements. We have them. They exist. Here is our center. From which our coordinates will determine where we're going to be drawing our boundary box around that wall. Here is our scaling. Did I not change that? I'm pretty sure I changed that. This is not supposed to be scaling anymore. This is supposed to be args. 7. Whatever are you talking about? Oh, why is that not there? There we go. How has our slime even been functioning this whole time? Settings. I should just set it so that it just clears all the dang time. So I don't have to keep redoing this? Alright, so that still works. Don't know why I didn't have that already set. Alright. So yeah, those things are already set to use proper scaling and whatnot. Okay. Trying to remember what all these numbers do. It's a lot. It really is. But in the end, you get, you know, get something cool you can work with. Oh, I am pretty tired though, so I don't know how long of a session we're going to get in today. I think in order for us to really make progress on this, we're going to have to go to a weekly thing and just move it to like a Thursday or something. Oh yeah, that's when I miskeyed the F into here for whatever reason. Alright, so our goal today, and even if we're going to just make it a short session, the thing I want to do is on the 8th one, I want to draw a circle around it. The reason for drawing a circle around it is to show us where our boundary is going to be. Alright, so we want to go into here. That's not what I want to do. Draw. I don't know if I spelled that right. Now we want to draw a boundary around it using our chords. So args 3 I believe is our context. Yes. Oh, I am forgetting how to draw a circle. Here we go. Perfect. Ah, it's arc. It's not even draw. Okay, but before we even do that, we gotta do... begin path. We're going to need our X, our Y, the radius. We know our sprite cells are about 60, so we're going to do a 30 for the radius. And then for the full circle, we go 0 and 2 times math dot pi. Yeah. Now what this is this arc method uses radians. 0 is our start angle, and that's the 3 o'clock position. Right here. Half pi, 1 pi is 180. and then 2 pi would be 360, so we put in 2 pi to get the full circle. Okay, now we need to translate our x and y coordinates. So we have chord translator, chord translator, but that's not all we need, is it? No, it's not. What we need args 6, 16, 8. Okay, this is probably going to be super confusing, but here's what's going on. Because our chords translator is returning a 2-element array, and those arrays are coordinates that are from the center of our map. See, that's not going to take into account scaling, though, either, is it? How are we handling scaling? Let's just see where this ends up first. Thing is, though, I want to change the color. Hmm. Is it fill style? I think it's fill style that I'm looking for. Sure. I want to go with green. I want it to stand out. Now, I don't think this is quite going to do it because we haven't scaled according to our scaling or anything here. But we might be close, so let's see what happens. Oh, what was it? ARGs. 7? Well, we're not getting an error, so that's good. But I'm also not seeing our circle. So either I'm not drawing the circle properly, or Let's try... Let's try fill. See if that does it. Could also be that we're just not getting any changes here because it's not refreshed the code that it's going off of, which is always an issue, it seems. Ah, there we go. Okay. Hey, look at that. Blue. Why is it blue? Oh, right. Because I told it to be blue. That's why it's blue. I wanted it green, though. There we go. Okay, 1, 2, 3, 4, 5, 6, 7, 8. We are not that far off. Although our buddy moves around a little bit. I don't think we've got some of our math in the right spot. I don't know if that's going to be the right spot either. We're going to find out, though. Screwed this up now, though. Okay. One, 2, 3, 4, 5, 6, 7, 8. So we're close. One of our coordinates is right. One of our things is right. We just got to figure out which one it is. Alright, so... I really don't know what our difference is on the two. Come on, nope. I need a slower snap than that, okay? I don't need all of that. I just need the X, because the X is correct. It's the Y that is not correct. So we're gonna copy this. Paste it here. I don't think that changed much. We're going to take this times our scaling. That's not what I want to do. Okay. And settings. Clear. We're still not quite there. It's see, right there would be about right. The size of our dot is scaling properly, though, so that's working. And it's staying pretty close to center. It's not quite right, though, is it? And I feel like one of these is off, because it's just... That dot shouldn't move up and down quite the way that it does, so one of these is off. Oh, yeah. Probably because this is supposed to be height. This is supposed to be that. Something's still not quite right, but we're closer. We are closer. Try taking this out for a second. But I don't know what Control D does, but now that's the sort of behavior I'm looking for. That right there is exactly what we want. 1, 2, 3, 4, 5, 6, 7, 8. However, it's over and up by about 30. Let's encase this so we don't mess with it no more. So we know that works. That is perfect. We don't want to mess with that. It's a bit of a mess, I know, but you know, you work with what you got. Okay, so we want to subtract. Might be going the wrong way. That might not be the right amount. One, two, three, four, five, six, 7, 8. Perfect. We have done it. We have managed to locate one of the walls. Now, that's a big, long, disgusting mess. I mean, just look at that line. That is an insane line of code to have to write. And to have to remember and to have to decipher. Like, we're going to look at that in 2 weeks and we're going to go, what were we thinking? Works, though. It absolutely works. It shouldn't. Really, in my opinion. This should be just an absolute disgusting mess because of how complicated that stupid line has become. I'm probably going to try to find a more elegant solution than that, because I mean, look at it. I mean, we're starting with, you know, this right here, this bit, just this highlighted bit. That's our X coordinate for the circle. And then we do that again for our Y coordinate, and that's just ridiculous. Like, that should not be a Y coordinate. Okay, we should be able to reduce that down, I don't know, as a function or something. We should just be able to bring that smaller, you know? So, I'm probably going to make another function that'll just spit out a number that we can use in place of that. Does mean having to remember another function, but it's a heck of a lot easier than trying to remember what all of this does. And we now know this works. Now, our radius right now is just the inside boundaries. Alright, notice our circle just touches the inside boundaries. Alright, our next step is going to be making it so that our little slime cube can't touch the inside of that circle. That's going to be a little tough. Then what we're going to do is we're going to apply this to all of the walls. Our square dude, our slime cube should still be able to move around, but any movement that puts him inside of the cube, or of the circle, will be prohibited. We have the X and the Y of where we don't want him to go, and we have the distance we want him to keep from it. So, in our user controls, we would want to look at these four case blocks, and we are going to add another if statement that's going to check the distance from the X and Y that we know. And as long as we are not within the boundaries, or going to be within those boundaries, we should be fine. However, we're going to have to do that later. We're going to have to do that our next coding session, because it is 11 o'clock. I know we've only been at it for about an hour today, but I have appointments I have to keep today, so unfortunately today I do have to call it short. However, I feel like we did something. I feel like we actually accomplished something, because despite how confusing and stupid this line right here is, I mean, just look at that. That is an ugly monster. We are doing everything correct. Like, I could run a for loop that substitutes this 8 for each of the elements in ARG 616, and we would have a green dot for every single wall. And that's what we're going to do here in our user controls, because we're going to have to cycle through every wall to make sure that we're not trying to phase through any of them. Now, I'm hoping this doesn't result in our code getting super, super, super bogged down and stupidly, ridiculously slow. We may have to come up with a more elegant way of doing this. But if we have to, we can set it so that we're not able to go past this line, this line, this line, or this line. And that removes a substantial amount of walls that we have to check for. So, you know, there's ways around it if we have to go that way. As for how we're actually going to implement it, we're going to try the simple way where it just checks for the location of all the walls, makes sure our little slime cube is staying outside the bounds of that by staying exactly his center point, and the wall center points are going to stay exactly 60 pixels apart minimum. And that should make it so that the only places he's free to roam are all the places that are floor tiles, not wall tiles. And then we'll use that same logic when we make our bad guys, so that they're not phasing through walls either. And then we'll use a similar logic, but instead of disabling the movement when our slime cube connects with the bad guys, instead of disabling his movement so he can't progress further, so he can't like phase through it, he'll take a hit. Now, I don't know if that means we're going to have to add hit points or lives, and every time he gets hit, he loses a life. I don't know. I mean, I'm building this in real time as you're watching. The game could develop in different ways depending upon what seems to make the most sense. Normally, when you make a game, you have a lot of these elements already planned out, already thought out ahead of time. Admittedly, I'm making it a bit more complicated than it needs to be, I'm sure. But in the end, we're going to have a pretty fun little puzzle game where you're going to navigate this little cube dude through a maze to some location. Alright, I don't know exactly how I'm going to set that part up, but I think, because we now have it where we can just pick any one of them and we can draw a dot. Well, within the bounds of this this square, as long as it's not a wall, it's an open space. We could randomly generate an exit point and make it so that you have to get to it. And then, each time you pass a level, it'll add a point or something, I don't know. We'll see. We also want to make it so that he's not just a stationary face that slides around. Because if you remember, we've got a whole sprite sheet for this guy. He can look left, he can look right, he can blink. We want to implement some of those things to give him life. Make him not just this flat two-dimensional character, but give him a little more quality to his character, and we'll be able to utilize those. I'm not saying we're getting to that next time, but that's something we're going to get to. It isn't totally forgotten by me. We're going to get to it. I just kind of wish I had more time today. I just don't, though. But we did successfully put a green dot on one of the walls. So, hooray! We did a thing. We did. We did a thing. It happened. You were there. You saw it. Next time, we'll see about trying to put a green dot on all of the things and making sure our slime dude can't pass through any of them. But we'll hopefully still be able to move around. That's where, if you remember right, we still have this, where is it? Is it in script? Yeah, this one. That's going to measure the distance between 2 points. That's going to come in super handy, because now that we have the coordinator translator thing figured out, and we're getting actual X and Y. I mean, sure, this is a bit complicated of an X and a Y. We can compare that to the location of our character, determine how far away he is from a wall, and disable his ability to move in a particular direction if that movement would bring him too close, as in inside of the wall. That's the logic we're going with here. That's what we're going to try next time. I keep misappropriately naming my video titles because today it was supposed to be the squishy innards of our hero. We never got to the squishy innards of our hero because we ran out of time. I apologize. Hopefully next time. Hopefully next time, because well, it's not even really our hero we're going to be messing around on the insides of. It's the this stuff. Although I suppose we could put the function to check if he's even able to move in that direction inside of our move function. And then when our controls call that move function, our move function would just do nothing. I think that's how we'll do it. I think that's how we'll do it. Anyway, thanks for joining me. Tune in Friday for probably some more Link's Awakening. We're gonna be back on the Switch. We have what, two dungeons before the Windfish left to do. And we'll get to those. I'm gonna wrap up that game. At some point, I'm still planning on getting back to Metroid, because we just kind of left off in the middle of Metroid Prime and Metroid Fusion. Yeah, we're gonna see a return to that. Also, later in the evenings, I am planning on streaming on a somewhat regular basis with Zeph. There's a game she and I have been playing online, Elder Scrolls Online. I'm sure a lot of you are familiar with it or have heard of it. Some of you may have strong opinions about it. We don't care. We're playing it. It's fun. We enjoy it. You don't have to enjoy it. We're not going to force anybody to play it. Anyway, so join us for all of that. It'll be fun. It'll be fun. Be sure to, do the whole clicking the follows and subscribes and whatnot to be notified when I'm live, all that fun stuff. You know what to do. It's Twitch. You know how to do the things. Do the things. Anyway, we will see you next time. And I'm going to stop saying that now, and I'm actually going to go. Bye.